In this video, we're going to look at topic 97, example 1, understand logarithms. So in 97.1, understand logarithms, they want us to solve the equations 2x equals 8 and 2 raised to the x power equals 8. Let's keep this quick and simple. Let's start with 2x equals 8. We've done this thousands of times before. We're looking to undo operations, right? So you would divide to undo the multiplication, and you would solve for x, and x would be equal to 4. Okay, it's quite simple. Again, that's not new, but we want to remind ourselves that we are undoing operations. Okay, that's how you would solve an equation, is to undo operations. I'll say it a couple more times. So now here, the operation 2 raised to the x power equals 8 is exponentiations. You won't have to say that a lot, so don't worry. To solve this equation, you need an inverse for exponentiation that answers the question, to what exponent would you raise the base to get 8? Now, at times, you could figure this out in your head and think, all right, 2 raised to what power is equal to 8? But we want an actual process for when problems get more complicated and more involved. So the inverse of exponentiation is called the logarithm. And to solve the equation 2 raised to the x power equals 8, so this equation right here, you can write this equation here. Now, this would be read as, this is the logarithm logarithm base 2 of 8. Or for short, we would just say log base 2 of 8. Okay, that's how you would read that. So you want to be more familiar with this one. We're going to say log base 2 of 8 equals x, obviously. So solving this, if you were to solve this, and we'll get into more detail in the next couple of videos on how to actually solve these, the log 2 of 8, or log base 2 of 8, would be equal to 3. Because 2 raised to the third power is going to give us that 8. So the equation here, 2 raised to the x power equals 8, using logs, which again, as the videos go on in the next couple lessons and explanations, we'll learn in more detail. But we're asking ourselves, what can we raise 2 to the power to get 8? In this case, x will be equal to 3. All you're looking at, and I'm going to kind of end this on a shorter video, you're undoing operations, right? The first example, you use division to undo multiplication. The idea and what you want to take away from this video is that you use logarithms to undo exponentiation. Okay, they're undoing operations. Just take note of the statement down here. So the logarithm base b of x is defined as follows. Couple parameters, b has to be greater than 0, b cannot be equal to 1, and x has to be greater than 0. But the logarithmic function y equals log b of x is the inverse of the exponential function y equals b raised to the x power. So again, just one last time, we're looking at inverse operations so that we can solve functions or equations with exponents as variables. That's it for this one. The next couple of videos will go into more details on solving these and things like that. That's it.